Testing, testing. Oops. Sorry, it looks like my mic volume is a little bit low. It's way low. Give me just 1 second and we'll get started. Check, check. Check, check, check. Sorry, just trying to get the volume set up here. That looks good. Okay. Cool. So we're good to go now. Move this around. All right, welcome to Study Hall, everybody. Today I don't have any specific plans. Just thinking about going through some of the material and maybe doing some Code Wars problems for a change of pace. If anybody's got any questions, as usual, feel free to just put them in the chat in the Slack thread, and I'll get to them as soon as I can. There we are. I'm just pulling up the Slack thread on my phone so I can see it. Cool. All right. So it looks like last time we got through the what was it, the Python basics section. So next up is variables. So we can talk a little bit about variables today. And yeah, let's just start with that. So I think variables are a pretty straightforward concept, but there's a few, just kind of conventions and names for things that are worth kind of covering. So let's just make a simple variable here. I'll just say a, and a variable has a name that we get to choose for it, and a value that we get to assign to it as well. Somebody's saying they have a question here as well. Yeah, feel free to post that in. Looks like we got one. I'll just get through this real quick, and I'll take your question in just a minute here. So variable has a name that we get to choose it, so we can call this anything, anything we want. I could call this poodle monkey equals 3 or something, but probably there's a better name for that. We'll just call it A. So A equals 3. This is just a simple variable. The name portion of the variable is sometimes called an identifier, or just the variable name. I'll usually call it an identifier. That feels a little clearer to me. You'll hear me say, you hear me call this equals. I'm trying to train myself out of that a little bit, but it's fairly common to hear this called equals in this context. It's technically incorrect. This is not checking for equality, at least in the way we think about checking for equality in Python and programming languages. So it's not checking for equality and evaluating to a Boolean true or false. This is assigning a value to an identifier. So it's creating a variable. So this is the assignment operator. We call that the assignment operator. That's the proper name for that. And then this is just the integer 3. So that's the value. So we're assigning the value 3 to the identifier A, or the variable name A. Then now that 3 is stored in A here, I can access that value, whatever the value of the variable is, by just using A, right? If I want to just print it out, I can print it out. And I can treat this variable as the type of the value that it holds, right? So I can treat this variable like an integer, since its value is an integer. So if I ask for the type of this variable, I don't really think, some people will describe this as variable, as the variable having a type. I just think about it like the variable holds a value, and the value is the thing that has the type. So that's the way I like to think about it. So 3 is of type integer. You can see if I get the type of A, I get a class int, which tells me it's an integer. I can do A plus 5. Obviously, that's going to give me 8, right? Since A evaluates to its value. So that's basically variables in a nutshell. Cool. And let me jump in. Let me change gears here a little bit and take this question. This is challenge 4. Challenge 4. All right. Let's see. Okay, so this is another OOP challenge. These ones are always kind of fun. Let me just pull this up here. Okay. So this is getting into a programming paradigm that probably a lot of you have heard of, called object-oriented programming. Usually we we'll just refer to it as OOP for short, because object-oriented programming is a bit of a mouthful. Oops, didn't need to change the size of that window. So object-oriented programming, I want to give some context to this for anybody watching, and to the person asking, because I'm not sure where you're at with this material, but with this one, object-oriented programming is an important concept I'd say in programming in general, like as on the whole, or as a whole, that's what I meant. As well as Python specifically. Python is an object-oriented language. the way that most of our material is structured, almost all of it is not centered around object-oriented programming. So Python is technically a multi-paradigm language, and we teach a type of procedural imperative programming that's uses sort of fewer tools, and it's designed to be approachable and easy to learn. The programming paradigms, I really like getting into different paradigms. Well, how do I put this? They don't allow you to do necessarily different things. They allow you to do the same things in different ways, right? So if you take an object-oriented approach to something, you, in all likelihood, are solving the same problems that you could solve in a procedural imperative way. You're just doing it differently. You're doing it under a certain paradigm, right? So we teach, like I said, we teach imperative because it's sort of, it uses fewer things. So it just gives us fewer things to teach. And it's sort of this idea of like just getting you up and running with this, like the simplest, smallest set of tools that gives you a complete set of tools to do problem solving. So I'm just giving some context for this because I want to make it clear, like you don't need to know object-oriented programming to get through the TI. There will be no object-oriented programming requirement for the technical interview. We'll just ask you to write a few functions. That may change in the future, hypothetically, but for now and for the foreseeable future, at least, it's going to stay the way it is. So, but we do have some OOP stuff kind of sprinkled around in the weekly challenges. So it's a fun topic, and it's a topic that you'll get into more in the DSI and after the DSI. It's something that you'll learn eventually, but I just want to make it clear, like, you don't necessarily have to do this to like be ready for the technical interview. Okay, cool. So disclaimer complete. All right. So let's do some object-oriented programming. So the next few OOP questions will cover doubly linked lists. So we're gonna essentially write our own sort of list-like data type, and we're gonna use object-oriented programming to do that. So much like the singly linked list SLL, the DLL is a list like data structure where nodes store both the data and the connections to the other nodes, unlike SLL, which can only be traversed through one dictionary, or only be traversed through in one direction. DLLs can be traversed through in both directions because each node contains data for the previous node as well as the next node. So there is an SLL challenge from a previous week, a singly linked list. And if you don't know about this, here, let me just paste this in. The idea is, with a singly linked list, if you think about how you'd construct a list or a linked list, there's a data structure called a linked list. So these are just variations on that. So the way you could construct a linked list is you have each node. So your node is just going to be some collection of data. I'm doing this as a tuple kind of in Python, but in my text editor here, but we can just kind of think about this as more abstract than just code. And then each node will contain your value and a link to the next item. So link to, let's see, next node link, right? And this is a singly linked list, and a doubly linked list will also have a previous node link. So essentially we have an instruction to find the next node and the previous node. So you can see if I have links, if I have a data structure that looks like something like this will be, how would I put this? This would be the first node. Let's do node 1, and then this will have whatever value we have in it. Let's just say, I'll just keep that as value. We don't necessarily know what that value is. And then we have the next node as well. So the next node will be, oops, node 2, and then we'll have node 2 as well, which will have node 3, etc. And we'll have node 3 there as well. So that's kind of the structure of this. All right, cool. Let's try to get through this. This is a big one. This is going to take a little bit to get through, but we'll pick away at it. Okay. So much like the singly linked list, the DLL is a data structure where nodes store both the data and connections to other nodes, unlike SLL, which can only be traversed through in one direction. Sorry, and that's kind of what I was kind of trying to show, right? If you think about like each node containing a link to the next node, we can only, starting at any given node, we can only know what the next node is, not the previous node. So if we want to, which means we can only traverse it in one direction. Basically, we can start at the beginning and go from left to right, as it were, or we can go from right to left. I don't know if I think the screen is inverted there. Sorry, but yeah. Anyways, okay. So this challenge will require writing 2 classes. So first, write a class called node. So let's just start with that. We'll do class node. Oops. Give me 1 second here. Okay, sorry about that. I'm just going to say pass. We'll come back around to that in a second. So this class should take a single parameter, presumably for initialization. So it's going to have an init function. So def init will take self and val. Let's see where it is. first class called node, this class should take a single parameter, which is the value to be stored in the node. Okay, so let's write a test for this. We'll call this my node equals node with the value 3. Print my node. Okay. In the init. Oh wow. Okay, wait. Let's see here. So this class should take a single parameter, which is the value to be stored in the node. In the init method, it should set 3 attributes. Okay. So first, second, where's the third? Third, there we go. There we go. Init method should take 3 attributes. The first value is the value being stored in the node. The second attribute should be called, let's see, sorry. First is value, which is stored, which is the, okay, sorry, this is worded in a bit of a strange way. So the first attribute is going to be called value. So we'll say self.value equals val. That's what this is. The second attribute should be called PRV and have a default of none, and the third should be NXT and have a default of none. Okay. We'll do that. This will be PRV NXT. Okay, and then let's write a quick representation so we can actually print this out and see what this is going to look like. Dunder repr. Oops, repr. We'll just take in self, and we'll return an f string of, I think I'll just do, let's just do this. Okay. So this will be self dot this, self dot this, and self dot next. Okay. So this will show us the value, the previous node, and the next node. And right now these should just be none. So when I print this out, we should be able to just see that. Oops. 3, none, and none. And then if I pass something else, 57, 57, none, and none. Cool. Just for context, let's look at what this dunder repr is doing. This is a representation. It's going to allow me to define what this is going to look like when I print it out, basically. So if I don't define a dunder repr, you can see that this is what I get. I get some lib.node object at, and then some location. I don't know if this is directly a RAM address. I kind of think it is actually in hexadecimal, but it's describes some location in the program's memory. So not really very useful. I probably want to see something else. So this will actually let me see what's going on. Okay, so that looks like my node class is done there. So the second class will be called, the second class will be the DLL handler. this class should be called DLL. Okay, we can do that. I'm actually going to get rid of these. Actually, no, I'll keep those tests around. I'll just move them to the bottom. Class DLL, presumably we're going to have an init, so we'll do def like that. We're going to take in self, and we'll probably have a repr for this as well. Okay. Second class will be called DLL handler, or will be called DLL and take in no parameters, sorry. The init should create 3 attributes called sorry, I'm getting lost in this. The init should create 3 attributes, start and end, both with values. I wonder if this is meant to be 2. Okay, well, we'll see in a second. Start and end, both with values of none, and count. Okay, I got you. Start. We'll do end. I'm just going to rewrite this default of none. Okay. I like to do this. I know it takes a little extra time, but it helps me organize my thinking, and then when I want to reference back up to it, I can just easily see, and it should create 3 attributes, start, end, and count. It just helps me think about what I'm doing. So count with, which should be initialized with 0. Okay, now I'm just gonna kind of do this. Self.count, and we'll call this, start and end, like that. So these 2 should be none, and this one will be 0. Okay. Add to DLL a push method. Let's do this. Push method that adds a node to the end of the list. When adding a node, it will need to be connected to the previous node in the next attribute of that node, okay? But also in the previous attribute within itself, okay? You're encouraged to also write a function that will print the DLL forwards to backwards and backwards to forwards to ensure that it works, but it will not be tested. Okay. And then this is just a link to the SLL challenge. Okay, so push. So we're gonna define our own push method, and I'm not sure what to do for repr here, but I'm gonna keep it around because sometimes it occurs to me and then it's easy. Okay, so we'll say def push. I'll take in self and val. Oops. And let me see, how do I start with this one? I'm trying to think of how to do this in a way that I don't just like write it out without kind of explaining what I'm doing. So push method that adds to the end of the list. Adding a new node, da da da. So what we're going to do with push is we're going to start off by calling a new or creating a new instance of node here. And we'll just call this new node. And we'll set it equal to node. And we'll take in the value. And we can say if self.count node equals 0, or if self.count equals 0. So what this is saying, sorry, I didn't really give context for this. Self is sort of a keyword that allows a class to refer to its own methods and attributes, basically to itself, right? So this is the self is the name it calls itself. So this is like saying dll.count. This is gonna allow me to access that count. So if the count is 0, then I know that this is my first node, and I have some special logic that I want to do to this. If it's not 0, I have a different set of steps that I want to take. So what I want to do is say if the count equals 0, in other words, let's say if this is our first node, we want to set self.start equal to new node. And we'll set self.end also equal to new node. And then we'll increment the count. So we'll say self.count plus gets 1, just like that. And then else new node.prv, that'll be our previous, equals self.end. So imagine we've already pushed one node onto here, right? So self.end already has, if we're pushing a second node onto this doubly linked list, self.end has the value of what is now the previous node. So we're going to set new node dot previous to self dot end, right? And we're going to set self dot end dot next equal to new node, which is the node that we're creating, right? So imagine, for context, this else code is creating a second or second or third or nth or whatever node. So we already have a node in this list, right? So our previous node can be set equal to what's currently the end. Since the value of self.end was set as a node, that node, if we look up here, has has a previous and a next property, right? So we can set self.end.next to the current node. Yeah. Then we can set self.end equal to the current node as well, the current new node, I should say. And then again, same thing, we'll just increment the counter and we're good to go. Let's do that. Okay. Hopefully that's clear. I think I should go through, I think I need to start making videos for these again. Yeah, I always kind of need to like think about like extra hard about how to explain what I'm doing in object-oriented programming. There's like a lot of, there's a way that object-oriented programming can kind of feel unnecessarily convoluted, because kind of sometimes it is. So yeah, I feel like I need to like come back and maybe make a video of this and like really think about how to explain these concepts. But I'm kind of trying to fly through this quickly. Let's just test this real quick and see if it works. Cool, so that's gonna work. Cool. All right, hopefully that's helpful. Let me know if you have any questions on this. And if not, I'm just gonna put a minute on the clock to just leave the floor open for questions. And yeah, we can go from there.